Okay, right. Let's get going. Um, let's go through some open pull requests. I know Travis has been having issues, but we should really try and shoot through some of these anyway. Jack, have you done anything with 1072 since last week?
Yes. So although it's not passing, the last time I ran the code, everything that failed was due to not being online or something like that. So there was no failure in my code. So I can re-edit it and resubmit it if you like, and then go through the whole Travis stuff one more time if you really want the Travis to give it the thumbs up.
Okay, I'm happy to look past the recurrent Travis fails that have been occurring because they seem to have magically fixed themselves. Although, what the hell is all this internal error stuff? That's not the normal fail.
Do you want me to, I can make a small edit to the slightly more verbose documentation, then resubmit just to try it again, see if I can reproduce internal errors.
Yeah, if you've got an edit to make the edit and we'll see whether it fixes itself.
Well, I mean, I don't have an edit to make. It would just be for testing Travis as much as anything else.
Merge master into the pull request if you've got nothing else to do.
Okay.
Although there is a comment, Simon has a comment open, and also your documentation needs updating.
I did all that.
There's a according to GitHub, you've still got an example of indexing a map cube with MC0.
Okay. I will fix that.
Hey everyone.
Testing.
Sideways out.
Oh, can you hear us?
Yep.
Yes.
Jack, why is your video green?
I put a sticky over my video camera.
Why not just turn your video off in Hangout so that it goes back to your picture rather than your green? Whatever.
You're setting a lot of redundant pixels over the internet for no.
You see, I can't trust that little green light on my Mac laptop, but I can trust a piece of paper.
You can do both. There's no reason you have to take the sticky away. Turn the webcam off and stick a sticky over it if you really don't want to show the internet your face.
Okay. I kind of like the green, but you know, it's soothing.
Okay, other pull requests. What else we got? Travis Y.
Sorry.
Oh, cool. Now on the pull request page, you can see the number of items that haven't been done in a pull request.
You used to be able to do that. It's just they've just made it prettier.
Yeah, it's much nicer now.
Okay, 887 has a Sphinx fail in it. That's just dead.
I wonder if it would be worthwhile to create a label called like meeting or something. And that way you can have a list of all the pull requests that are going to be discussed in the meeting.
What the hell is this internal error nonsense, Travis?
Easier. You know what I mean?
Well, mostly I go through the ones with review and any ones which are vaguely controversial.
Yeah.
Okay, 1095. It only had a Travis error on it, so I'm happy to ignore Travis and move on. Although it's conflicted, so we can't merge it anyway.
Is that mine?
Yeah.
Okay.
Rebase needed.
I'll fix it.
Okay, 1097 Fermi data. Andy, is this the one you spoke to me about on IRC with the licensing issue?
Yes, but I think that's all resolved, so we shouldn't have any problems.
What was the outcome of that?
I talked to the guy in question who wrote the software, and he said that he had no problems at all with it. He sent that to me in an email, so I just added an acknowledgement in the code as a comment that some of it was based on his work, and he said that was absolutely fine by him. He seemed rather surprised that I had bothered to ask.
Where is this comment?
I don't.
Still, good practice, good practice.
Absolutely. So I just triggered Travis again on this one because I realized I'd done something stupid. It's in one of the functions.
Whatever. HDU. Oh, come on! No, I don't like this pull request anymore. This data is flawed.
Oh yeah?
Yeah, this is a future problem, not a current problem. But lots of light curve. Well, no, actually, the Resi light curve and this light curve appears to. It uses data from different HDUs for different things, and this fundamentally breaks the SunPy IO/map factory approach.
Really? I don't understand.
Well, the SunPy IO assumes that every FITS HDU is independent from one another.
You don't have to worry about it, Andy.
Yeah, don't worry about it at the moment. I was just. I don't know how I'm going to get around this problem.
That one's above my pay grade, okay.
Anyway, doesn't matter. Okay. You have a lot of line breaks at the end of your files.
Sorry. I'll fix it.
I'll go through this and have a look at it properly.
Yeah.
But it's looking good. This should be reviewed properly. It looks generally very good. So,
Yeah. Okay.
has anyone got any other PRs they want to talk about?
Do we feel like there's some PRs that are kind of been floating around there? The point of having them there is not to accept them, but to kind of generate discussion. But discussion has basically died. Should we clean them out and have them kind of re-PR'd if they're ready? For example, the worst case is the hypermap.
Yeah, that should go. I'm just going to close it.
Okay. It's just been sitting there forever.
Why haven't we merged the peak one? What's going on with that one?
The what one fixes to peak?
1086.
I think I'm going to put them in.
There are lots of
Yeah, it's not good.
comments on it. Sorry, guys.
Well, get on there.
Is that finished, Steve? Should it have review on it? I mean, is it feature complete?
No, I don't think so.
Okay.
Actually, I wanted to ask you, is there peak for the cube, map cube? I know there's a map cube plot that does something weird. But
No. Peak for MapCube loads an interactive visualizer. Plot returns a matplotlib animation object.
Okay, so I don't need to worry about fixing that.
It follows the same principle where plot is fits into a matplotlib workflow, whereas peak is separate.
Yeah.
It calls show, and except the MapCube takes it a bit further because it spawns an interactive object.
Yeah. Okay. The other question I have for you guys is, the original idea for Peak was that it would show you kind of a quote-unquote standard plot, but there may be a lot more data in whatever data source we get the standard plot from. So essentially my question is, if we have a data frame for like a leg curve, and it has many more parts to it, many more than like quote-unquote the standard, does the peak command, do we have it plot everything? Or essentially what I'm trying to say is, does the peak command want to like feature some data at the expense of some of the other data that may also be there? Or do we want it to just kind of let you see everything, similar to just, data frame.plot, which will just indiscriminately kind of plot everything? Does that make sense? But so that would break this idea of peak. For like the goes object, for example, the goes peak shows kind of a quote-unquote goes plot that we're familiar with.
At the expense of what?
At the expense of putting the other stuff in there.
Do you have a particular data source in mind that has this problem?
Yeah, so the solar indices plot, like the solar activity cycle data source, Currently, the peak command will pretty much just show you like the quote-unquote standard solar activity plot, which shows you sunspot number as a function of time. But there's actually way more stuff in there. There's the what is it, F70, F17?
10.7.
10.7.
What kind of solar physicist are you?
F10.7. Radio flux is in there. There's both the measured and also like some model. There's actually 2 data sources for the sunspot number, the Zurich number and the other number. So currently, Peak just shows you the sunspot number and pretty much ignores all that other stuff, but it's there.
See, my gut reaction to that would be it should plot everything, because if the user hasn't used it before and creates a plot to the object and doesn't see that the data's there, they may never realize that there's that data in that object.
Yeah, I kind of agree to that, and I kind of like the idea that if we go in that direction, then we can standardize the plotting kind of across everything and just say, this is the way you do it. Don't start making special plots for certain things.
I mean, you still have special plots in how you choose to represent this time tag data versus this time tag data.
Yes. So, like, for the easiest example is whether you want log scale.
Right.
Right. So some data is definitely better log scale than other data. So then we have to understand how to carry that around, I think. So
changing matplotlib defaults for different plots is fine. That's logical, it makes sense, because some data should be on a log scale, some data shouldn't be on a log scale. Having default things that can be overridden by the user using the standard matplotlib interface is logical. There'd be no point us having the object, the methods, if we weren't doing that. But not showing some of the data seems quite a different argument to that.
yeah, like the ghost plot, for example. I mean, I keep going back to that because that's the one we've sort of customized the most. It has, it shows the light curves and the quote-unquote right colors, blue and red, but then it also adds the other axis with the X, M, C, the GOES class on the right-hand side, which in a sense doesn't really break the model, but it is kind of highly customized compared to other plots.
I would have thought of the peak as a quick look plot, and so it should just present all the data, but in some way that's convenient for that data source. So in that sense, I would expect different formats for different sources to some degree. Obviously, you want to standardize as much as you can, but it's not going to be possible to be completely the same.
Yeah. Also, I'm still happy for peak and plot to do different things.
Yeah.
Different levels of customization.
I think we're all agreeing here that all the data should be standard. So I'll go ahead and move ahead with that on the peak side of things. And we can continue that discussion on there. I'm actually creating a little, so associated with that PR will be a notebook that shows you all the new plots. You can actually go and look at them all.
Okay. That's good. Got any other ones that are in need of a...
What should we do with this dictionary formatting thing?
The order dictionary thing?
Yeah.
What was you talking about the bug?
No, it's not a bug. It's just that the string representation and the representation are not very nice.
Oh, well, since we're using order dict, which comes from SunPy, right?
Yeah.
Then I think that we need to correct it in SunPy.
Yeah, they're supposed to be working on a change, so maybe we could just wait for them to do that. It just annoys me in the meantime. Because I look at order dictionaries all the time. like, you know, want to see it in a nice format. But I can just keep that in my personal folder, I suppose.
Yeah. What your PR here is to try to fix that or something?
It is, but I'm not sure I did it the best way. First of all, because obviously we import the thing from SunPy and then I basically hack it.
Have you checked out that pull request? SunPy pull request.
I did a while back, but now it's gone from my memory. I should have another look at it.
I think we should just leave it and let SunPy do it.
Chris, I got a question.
Hello.
Hey.
Yeah.
Question.
That's fine by me. Looks like they're still working on it.
So do you want to cancel this PR then?
So our problem is
Maybe yes. If they're gonna do it anyway, but well, especially if it doesn't bother anyone else, then it's not an urgent.
No, it is annoying, especially when printing fits headers. But
we can actually compare the
it's not.
reference image. That is what we're trying.
It's not.
Since we don't have any point in here, why do we have
Massively urgent, I wouldn't say.
Yeah, yeah. I think you're right. We should just close it and then we'll leave it to SunPy to fix.
Well, I guess one thing you could do is there was no represent function for like curve, right?
No.
So just choose.
That was new. I added that as well because I guess I just had it on my mind.
Yeah, that should probably stay.
Definitely stay.
Okay. Well, I can make a clean PR with that.
And remember that it's string now. Okay.
Yeah, I changed that to string. Which
Which
I understand the argument. It makes sense to me.
In this PR,
There's no reason why you couldn't have a nice representation as well, a Reaper as well.
Yeah.
But the Reaper has to be unique to that instance.
Yeah.
Okay.
There is a
there was
reason. Reaper is supposed to be unique to the specific instance, which is why the default ones will fit the memory address.
First is where we
Okay,
can
I see. Yeah.
subtract the intensity.
So you can do both. Just add in the memory address or something.
That we can't find.
Yeah. Okay, I'll work on that.
yeah, and maybe you could edit the title of the PR.
Yeah, I think I'll just make a new one.
Shall I close this or what do you want to do?
Yeah, you can close it. I'll try to use git cherry pick and see if I figure out how that works.
Unfortunately, there are points on what we are doing doesn't have personal values. So we can actually
I'll make a comment on that thread that we're gonna leave it.
and a similar line.
Yeah, we should definitely. Perhaps you could go and test out the SunPy pull request and contribute to that. Because
Yeah.
we should. We should. Good.
Yeah. Okay.
Taken.
done a really good job.
That
I think-
Ashish's Spectrum PR is ready, right? Yeah, it's not here anymore. I thought he was.
It's like 4 months now. Okay, from like
1121.
now. It's just that
4, 1, 2, 1.
Yeah, well, it's worth a go. Because except for this,
2,
I
1.
don't find any of the
1, 1, 2, 1 is an open. What? Oh, 1, 1, 2, 1.
Oh, he hasn't fixed it.
Function to confer players going past into cooked here. Yeah, that's not finished. Oh dear. We're going to bed of course there. Yeah, we're minutes.
Don't work.
I'll go back home.
What's going on with the ephemera stuff, Debbie? 1070. You're muted, David, by the way, in case you're trying to speak. Very good,
Okay,
Stuart.
now. Sure. No, I have to find time to write from the book and start to add stuff there.
Okay.
I have the book on my desk. And little by little, I will start to add the function there. And the important thing that I want to make so everyone notices that I'm not testing it against the values I make in a calculator. I took there is another equation from the U.S. Nautical Almanac office, and they had like a simplified equation. So I'm using that simplified equation to test the proper one that I put in the code.
Okay.
And I will do with the rest whenever I have a bit of time.
What about Dan Ryan's 2 PIs, which I thought is the file search one and the other one converting flare class, no, temperature emission measure for GOES. David, did you talk to him about that?
Say that again, which one?
1067. Functions to calculate GOES radiative losses.
Yeah, I think more people need to review that one.
Well, I thought we had agreed that it should be an affiliated package.
No, that was
Yeah.
something else.
Oh, that's something else?
Yeah.
Yes, that was his tabs software.
Ah.
So this is still something for SunPy, I think.
I haven't looked in that one in detail.
Okay.
Yes, I haven't had a chance to review this. I will stick the review label on it.
That's the one about Chianti files and all that stuff, no?
I think this does have further Chianti issues. Maybe.
Yeah, it has some lookup tables in it, I think.
Yeah, it definitely does. I'm not sure where it gets them from.
I just wonder how hard it would be to run a Chianti web service. Because all you'd need is an Amazon EC2
There
instance
is one. There
with more
is
compute
one.
power than God.
Hello.
Go on.
Sure. There is one. There is the project called VMDC. It's and I know half of the people there because they were in Helio as well. They are creating web services, not just Chianti, but other atomic databases.
Where is this?
I'm copying the link now to you. There you go. So in principle, they have web services, so you could query them. They're still in development, but I don't know how far they are.
They already have a Python interface. Oh, it's called Chianti Py. Okay, that's boring. I thought it was to the web. I was getting excited for a second then. That's Chianti.
I can ask to the.
Okay. Could someone who knows something about Chianti look at this? Because this might solve this problem. We just write a net client for it and query it.
The guy who's building the web servers is the same that built it for Helio, so I might ask him.
Okay. Look into that. Because, you know, not relying on SolarSoft data files would be a nice thing.
Well, probably they're based on SolarSoft anyway.
Oh, sure, but as long as we don't have a direct dependency on SolarSoft, I don't mind. Okay. By the way, I enabled and configured this waffle thing.
That.
Yeah, waffle.
That's good. Good morning,
See ya.
That's to discuss the pull request that we have to discuss every Monday.
What is this? I'm confused.
On the chat.
So this has columns based on the status and labels of various issues, including pull requests. So everything in the ready column has the review tag on it. Everything in the in progress column has the work in progress tag on it. Done things have been merged, and backlog is everything else.
Why is there even a done column?
And why are there such weird things in the done column? Like the hypermap, clearly not done.
I think the done column represents recently closed things.
Yeah.
I wonder whether I can...
Wait, so does this provide any other capabilities except like putting things in bins?
Which there already are, because we can do
Labels are kind
label filters, right?
Yeah, it isn't massively exciting. Just thought I quite like it as a little way of looking at the columns. You can also drag stuff around to relabel it and whatnot. But
Oh, okay, that's a little neat.
Wait, does the relabeling go back and relabel them on GitHub?
yes.
Oh.
So if I...
But you need permissions to do that.
Yes, if you log into Waffle using your GitHub account and you have the correct permissions on GitHub, it will automatically do it.
Oh, I see. Okay.
It's just a little toy. I just thought I'd show people it.
Yeah. It's kind of neat.
Okay, I think British is going to show us the coordinates package.
Okay.
Rather short presentation on the coordinates package, you mean?
Yes, that's fine. Short is good.
Okay, I'll just post the link here. I'd like to warn you guys that my net is rather unstable, so if I disconnect in between, don't get too shocked.
Do you want to also share your screen as you go through it?
I thought we're doing it with the notebook. I mean,
Yeah, but you can do it in the notebook on your screen. It's just that if you do it on your screen, it goes onto the internet forevermore.
okay. Is it sharing it?
Not yet.
Can you guys see it?
Yep.
Yep.
Okay, so let's start then. My project is regarding the reimplementation of SunPy.wcs as SunPy.coordinates, and we'll be phasing out WCS at the end of the project. At least that was as was discussed. Now, the coordinates package was built on AstroPy's APE5 proposal, their model for designing coordinate frames, and we use a lot of AstroPy code to build our frames, so to speak. And in the SunPy coordinates package, we have 4 kinds of frames: heliographic, Stonyhurst, Carrington, heliocentric, and helioprojective. Each one of them subclasses the AstroPy base coordinate class so that they can be recognized as a frame class in the AstroPy graph. And specifically, the heliographic Carrington class subclasses heliographic Stonyhurst. This is a minor implementation detail because there's some stuff in the constructor that it reuses. Okay, let's get to the code examples. We will be using AstroPy's SkyCord class to provide an interface, so to speak. This is because the SkyCord class kind of joins together the details between different frames. I mean, for example, let's say you provide the date of observation parameter, and it doesn't carry on if you're using just a frame object. If we use a SkyCord object, it does carry on. This was a minor issue back then. I won't discuss it in detail. So let's just get to using the SkyCord class.
Are they planning on fixing that? Because SkyCord is confusing.
Actually, that's a known issue. It's supposed to be that way. Stuart and I had discussed it with the AstroPy folks. They said it's supposed to be that way.
What? I'm sorry. What? I missed this. What are you?
SkyCord suggests that you're talking about helioprojective.
Yeah, I'm a little confused.
It's any coordinate in the sky as a 3D object.
Yeah.
That's what AstroPy called it. They're not going to change it now. We're stuck with it.
Okay.
How?
So, okay.
We did propose a pseudo-chord class earlier, but that was struck down.
Yeah, the reason I don't want to subclass SkyCord is because we lose all of the interoperation stuff. So, for instance, Ginga just calls AstroPy SkyCord. So, because our stuff integrates with SkyCord, we get all the Ginga coordinate stuff for free. So we can't subclass SkyCord without breaking all of that magic and basically ruining the whole point of doing this in the first place.
Okay. Carry on.
Okay, so in the first code example, we see that we provided 3 parameters. These 3 parameters are, well, longitude, latitude, and distance. we provided the frame as a keyword argument as well as the date of observation. I mean, if we don't provide a date of observation, we cannot transform between frames. Just a minor detail. Okay, so first of all, I printed the SkyCoord object. You can see how it's represented. It also has an underlying frame object that stores the actual frame object, the sc.frame attribute. I also printed two specific attributes. One of them is the longitude of the heliographic frame. That is an attribute of the representation of the frame. There are two types of attributes here. One is an attribute that is part of the representation. That could be, for example, in this case, it's latitude, longitude, and distance. And the other kind of attribute is an object of the frame attribute class. The frame attribute class is a specific class in the SunPy code base. It specifies frame attributes within the frame. Okay, so I print both of them, and you can see their values here. Moving on to the second code example. Every frame has a specific representation. We can represent a frame in different ways. For example, Cartesian, spherical, cylindrical, and each frame has a particular default representation. It expects that the parameters that we give to it at the time of instantiation will be in that default representation. Or else we can, of course, provide a representation object altogether. Now, one more little implementation details. Stuart and I built this spherical wrap 180 representation class. This is to provide longitude wrapping. We did not have it earlier. I mean, I think Stuart can detail a little bit more about this.
It's because heliographic, by convention, runs from minus 180 to 180 rather than 0 to 360. So we just wrote a little subclass of an SunPy thing that changes that default. That's all it does. So that example there is what you think it is. It is instantiating a heliographic coordinate in with a Cartesian representation, which is something that you would probably never ever do, but you can do it if you want to.
Yeah, like I was saying, that we need to provide a base representation object, and Cartesian representation is a base representation object. So the three representation parameters are provided within the Cartesian representation object. In the Stuart is saying we won't really have to do that. When we print the SC2 object, we notice how it is still printed in the default representation, that is the spherical wrap 180. I can, of course, use the represent as method, and it will represent in other representations, for example, Cartesian and cylindrical. There is also this bit that the SkyCoord object has an attribute called representation. We can set it to whichever representation we like, and once it's set to that, it will change the representation that appears when the SkyCoord object is printed. Now, as I've noted in the comment here, it does not change the underlying default representation. So if I try to access X, Y, and Z attributes after setting it to Cartesian, it would yield an error. So when I print this, it gives me this. That is SkyCoord in Cartesian representation. The representation attribute is only for print purposes. That is correct. In the third coordinate example, I have provided a few examples of transformation. SunPy has this transformation graph, or they call it the bidirectional registry. In that, each frame class is stored as a node, and the paths between the different nodes are the transformation. It's a directed graph, obviously, because one direction to another will change the direction of transformation. Okay, that's all right. So as an example, I transformed the SC object to different frames, like heliographic Carringtons, heliocentric, helioprojective, and back to itself. The results can be seen here. Ignore the numpy.testing import. That was something I was trying but didn't work out.
If you can transform, or you can set a representation, I mean, what's the difference?
The difference between
Between setting a representation, which is doing it's just printing out the transformation or actually transforming? Seems like it's the same, pretty much.
On the surface, it may seem the same, but each of the, as I've described here, each frame transformation is described as a proper, well, function in the code. Now that function, the mathematics in that function differs from what we would be doing to just change representations within the same frame.
Yeah, the difference is the representation is Cartesian, spherical, or cylindrical, and that is a way of describing a coordinate in 3D space. Changing the representation doesn't change the point and doesn't change the frame. It doesn't change the origin of the coordinate system or anything like that. It's just instead of representing a point using longitude, latitude, and radius, it represents it using X, Y, and Z.
Right. And I've also described
a frame has a different origin or a different
Okay, so we've also described the frame transformation round trip here. The SC3 object that we've described here is, SC is in heliographic Stonyhurst. So we transformed to heliocentric, then to helioprojective, and then back to heliographic Stonyhurst to see how the values have changed. The values, as you can see, are very close, and if we round off, we'll be getting the same values. This bit here. Okay. Next bit is a few frame specifics. For example, we modified some frame constructors so that some of the attributes could be defaulted. For example, in the heliographic Stonyhurst class, its rad attribute is defaulted to the solar radius if no value is specified. Similarly, the L0 and B0 frame attributes are defaulted to 0 degrees, as you can see in the example here. B0 and L0 become 0, and rad gets the value of the solar radius that's stored in SunPy.sun. Also, the helioprojective frame has this zeta property by which distance can be calculated. We need to specify only the distance or the zeta property one at a time. We cannot specify both of them together.
Wait. What does rad is the radius of the sun? Why do you need... I'm confused.
I understand your confusion though. Rad is actually, think of it as the spherical representation. What attributes does the spherical representation have? Longitude, latitude, and distance. Actually, rad is the distance attribute. We've just given it a different name.
So why would you ever want to be able to change that?
Because it's a heliographic coordinate. If you don't want to be on the photosphere, you want to be in the transition region or in the. It's a full 3D coordinate system. It defaults to solar radius, but you don't have to have it in solar radius if you don't want to.
Okay, that makes sense. Okay.
Yeah, and as I was saying, that the helioprojective frame has the zeta property by which distance can be calculated. Okay, there's a glitch here that I went through when I was making the notebook, is that we have to specify zeta within the frame object. We cannot specify zeta as a keyword argument in SkyCoord. It won't recognize it. That's because zeta is a frame-specific property. Properties are not recognized by SkyCoord, it seems. So I had to provide a helioprojective instance to SkyCoord, as you can see.
Wait, sorry, what is zeta again?
Zeta is the distance. So in helioprojective, you can represent the z coordinate as a distance, to a positive distance towards the observer from the sphere that passes through the solar center. It's defined in Thomson.
Okay.
It's d0 minus d.
Okay.
And so, yeah, and if you provide distance instead of zeta, zeta will be calculated on its own.
If you're at helioprojective 0, 0, it's exactly equivalent to the heliographic Cartesian z coordinate.
Okay.
Okay, and the last bit is about some miscellaneous methods that SkyCoord has. Okay, now this I've defined SC as a SkyCoord object with each of the representation attributes being arrays. We can do that because even NumPy allows that apparently. So AstroPy has this functionality for it. They reason that instead of having arrays of SkyCoord objects, it's better to have arrays of attributes instead. Okay. A bunch of methods, for example, position angle. It calculates the position angle between two SkyCoord objects. So this example, it turned out to be around 4 gradients. Then there is the separation method that calculates the on-sky separation. Another little glitch I came across is that extra keyword arguments such as the date of observation parameter must be the same in both SkyCoord objects. I don't know why it's like that, but it was giving me an error, so I just kept it this way. And lastly, we have separation 3D, which works only on 3D frames. I mean, if the internal representation of a frame is unit spherical, it will not work. So it calculates.
How do you know?
None of the solar ones have unit spherical internally. Even Helio Projective is a full 3D coordinate system.
Okay.
Yeah,
Because
so separation. Okay. Okay. Sorry. Go ahead.
And I guess that's about it.
So the one thing you haven't mentioned, British, is our making up of the Z coordinate for Helio Projective.
I did mention the zeta property. Did I miss something?
No, I mean if you don't specify a Z coordinate to Helio Projective, it will assume that you want to be. It will assume that your Z coordinate is on disk.
Yeah,
So
and then
it will calculate the Z coordinate or not the Z coordinate, the distance, the radius coordinate for Helio Projective as if it was on disk. So it will have a defined value for on the solar disk and nan everywhere else.
Okay. So just to get a question about the big picture here. So this is all meant to get added to like the map class. So is the idea that the map class would have like arrays of these sky coordinates or something, or can these sky coordinates handle arrays? Like, I guess they must. The last one shows arrays.
yeah, they do. They do handle arrays of attributes. As I've shown in the last example.
Okay, so the map object would not hold an array of coordinates because that would have to be an array which was the same dimensions as the image and have to hold a coordinate in every point. What this is useful for is this is useful for converting. This is useful for representing points on the image. So if you say I want the physical coordinate for pixel 99, it will use AstroPy WCS. This doesn't, but ASIS will make map use AstroPy WCS to convert that into a whatever default WCS that fits WCS standard that map has in its header. It will.
Okay, so you'd say like map dot, I don't know, get chord or something, and you get a pixel value, and then it would give you a sky chord object back or something like that.
Yeah, if you ask it for a physical coordinate at a pixel, it will return you a sky chord object.
Right. Okay.
But what this also.
Sorry,
Go on.
Is there? You don't want to carry around arrays of these for a particular reason, just because it's heavy or something, or?
Yeah. Well, if you've got a 4K AIA image, you have to have a 4K array of these. It's just going to double your memory requirement. It takes about 10 milliseconds to spawn one of these objects. I know this because I've been profiling it hard today.
Yeah.
I would like to thank you for your demo, British. I would like to show, in sort of response to Steve's points, I would like to show this in action from the AstroPy side. This is something that I've been working on today. What am I going to share here? I share my whole desktop, you can get a load of nonsense. I'll share my whole desktop, maybe. No, I won't share this. So this is the AstroPy WCS axes package, which is I've talked about this before, and I've probably shown, you may have seen things that I've generated with this before. What this uses sky coord and the new AstroPy coordinates underneath. So what I've done here is I create an AstroPy WCS object like this. This is going, Ashish has taken this exact code and is implementing this as a map property. So you do map.wcs and you would get a AstroPy WCS object back that looks like this, or is created like this. So it uses the properties of the map object to generate an AstroPy WCS object. And then there's a little bit of magic here, which we're going to have to do something similar to in map to make map work properly. And what this does is it tells WCS axes that having a coordinate type HPLN and HPLT is represented by a SunPy coordinates.helioprojective object. And then we register this with WCS axes, and now it knows about that fifth type. And then WCS axes uses the standard kind of map.lib interface, so you create a figure and manually create an axes class to which we pass this AstroPy WCS object. And then from that we run, I'll just comment this out for a moment. If we run HMI map.plot, the only extra thing I have to do here is set extent to none so that our code doesn't mess with WCS axes code. And then we set, I want some white ticks, and I want some axis labels, and I want it formatted as arc seconds. And the net result of this, when I run it, is you can't see it. This. Which actually doesn't look very good because I've uncommented it. Fantastic. Let's try that again. Is this? Actually, making it bigger has made it harder for you to see here. So you can see that this has a nice overlay of tick points, and this is all calculated properly. So if you pass this a rotated AIA image, this would all be rotated. In fact, I probably try to prove that. So what that has done underneath is it used our coordinate object to do the transformation, or it created a coordinate object which WCS axis on top of it. It's also used to do all of its transformation, not SunPy.wcs. Let's see how this works. And because everything is registered on the AstroPy coordinate transform graph, it knows about all of the valid frames that.
So with the would the map have an axes object then?
So here we are. This is a rotated AAE image, and you can see that the ticks are rotated and everything is rotated because the map is rotated.
Why is the center of the sun at 900 minus 900?
It's not. That tick line is the line that goes across like that. See?
Oh my goodness.
So if I make this bigger, we should get. No, okay, hang on. Let me.
That seems like an improvement. I guess it's not changing. It's not changing the data, right? It's not rotating. It's just displaying it.
No, it's displaying it correctly. See, like that.
Right. So it's instead of rotating the data, it's rotated the axes properly.
Yes. Yes. Which is obviously the correct thing to do. Because changing the data is inherently destructive, whereas displaying the correct axes is inherently not. So if we can now do some coordinates magic like this. So we do ax.getOverlay heliographic stonyburst here, and that tells WCS axes all about the. It reads the transform graph, it finds a frame with that string name, and creates an overlay transform object for that. And we go ding, 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 and it takes a little while. This is why I've been having a discussion with Tom Robitaille about the speed of this today, because it is nothing shy of phenomenally slow. But there we go. So we now have a proper graph, and if we zoom in on a bit of it, again, please hold. The graph you are calling knows you are waiting. You can see that as soon as that grid hits the edge of the frame, we get ticks for the grid. So if I zoom up a bit more, like this. Come on! We're getting solar latitude ticks at the top.
Yeah, it certainly looks really nice.
Of course, we can go one better than this if we like. I'm going to flip back to the one that's the right way up. If we do heliographic Carrington, that won't work. That won't work. I'm not going to show you. It'll break.
Is it really slow because it's just doing it for every single pixel?
No, it's not doing it for every single pixel. So the reason is that it is doing every line separately, and there's a lot of overhead involved. We've profiled it, and it's not our code; it's AstroPy's code. It's the reason why it's slow. So it's okay. Like our transforms are about as quick as AstroPy's transforms. There's no major bottleneck in ours.
Yeah. So is the idea that a map will then carry, so the axes object is essentially like a bunch of sky chords, kind of, right?
No, it's something that knows, the axes object knows about the transformation. So it's something that knows about the transformation. It's not, it only creates sky chord objects as it requires them.
So it's using sky chord stuff in the back.
So the idea would be that our plot routine would create one of these axes objects rather than a standard matplotlib axes object.
Okay. So it's really just for plotting and stuff.
Yeah. Also, WCFX is pretty cool. There's a good SciPy talk on it actually. Has this got a link to the video? No, it doesn't. And this, of course, is the same, all the same infrastructure that the work on Ginkgo and the coordinate handling in Ginkgo has made use of.
Stuart, how does this work when the original data is not north-south aligned?
I showed you that.
Rotated. You're talking about rotated data, Jack?
Yeah, so Glasgow images are like 173 degrees off.
He just told you that. It just plots the axes rotated. It plots the data as it was taken. So the sun will be rotated in the image, but the axes will be the proper amount of rotated. Right.
Like that.
So is that what AI actually sees?
No. AI.
This is during a roll maneuver.
Yeah, AI only rolls every once in a while.
Yes, I know.
Yeah, this is a specific example to demonstrate this fact. But as long as there is valid WCS information that describes the rotation, and that information is abstracted correctly into the SunPy map attributes, this will work.
Okay. I'd like to see this with Glasgow data. That is all rotated.
Do you have a piece of LASCO data?
No. We can do this. We don't need to do this just now. So.
Yeah. Yeah. What would be interesting here is that if you're looking at HMI data, whenever you plot it, it would look like it's plotted upside down.
Yes, the axis would be back to front.
It is upside down. Yeah.
In fact, I can show you that.
I just think this is going to take a lot of getting used to. So, at least in my brain.
Doing it though. Obviously, if you rotate the background to solar north, pointing a line to the y-axis, it will plot that perfectly fine.
Okay.
It's better than what we do at the moment, which is assume the map is solar north correct, and just plot it like that anyway.
But in terms of the workflow, I agree with you, Jack. You would open the map, and then you get it, upside down, essentially like here, but it would plot upside down like this, and then most of the time, I think most people would want to, rotate the data so that, they can now kind of quote unquote fixed, and that would be that would force the users to do that consciously, right?
Yes. Yeah, that's. I need my serene green. No, this looks great.
Yeah.
But it will be a change for our users.
And there we are. That's what happens if you call rotate on the map before you plot it. It's the right way up.
Yeah.
So literally all I did there was stick .rotate on the end of the map call.
Okay.
So you have the option to do both, but the point is that we're not doing anything implicitly. If the user wants to rotate the data, the user has to rotate the data.
Yeah.
Anyone work with HI data? Do we know anyone?
It works beautifully for HI data. It's perfect.
Oh,
it's
really?
lovely. I don't have any to hand, but I have some examples. It's really nice.
I trust you. Show me in Belgium.
Yeah, this is congratulations to you.
Yes.
For this, and Stuart, this is really awesome.
There you are, Jack. There's a link in the chat. I found an old picture I made a long time ago with some HI data. So because HI data actually has both RA dec and solar XY, there's plot both on the correct grid.
But this does not take into account the reason why these coordinates are curved is because
of the projection.
Right.
Yeah, the grid lines follow the projection.
Yeah.
Again, with the not changing the data, changing the grid lines.
Yep. So that's the like projection tan projection, right?
Yes.
Which is currently not implemented in the WCS that I had translated over. Now
No.
very easily.
But we do get it for free with AstroPy WCS.
So this is going to be
yeah.
going to be great for Solar Orbiter, right? They've got HI style instruments on there, so
Yeah, we should maybe go back and make another case that they should be using SunPy.
There's also, along the lines of doing cool things with WCS, there's some effort ongoing. Tom Robitaille and various other AstroPy people are doing the ability to do reprojections, WCS reprojections. So you can reproject data from helioprojective longitude latitude into heliographic longitude and latitude in the carry projection, so it's the square projection. So you should be using this Skype transform framework and AstroPy WCS together. You should be able to go from an image in helioprojective coordinates, HPLN, HPLT, into HG, LT, HG, LN plate carry projection. So you create a, what's it called, map thing, rectangular map thing.
I have no idea what you're talking about. I totally lost you.
Example. Here, see this poster and see the image at the bottom left-hand corner, a heliographic map. And also the stereo one, where you can join two images together.
yeah.
Yeah. So all of that should be. AstroPy are working on that. We will eventually get all of that for wholesale free as well.
So you're just talking about merging images together, right? Essentially.
No, not just merging images together. You're changing the projection of the data. So on that page, there is an example of merging two images together, and there's also a heliographic map in Carrington in the bottom left-hand corner.
Right. Yeah.
The latter is simpler than the former.
Right. So.
But both are possible.
Right.
In fact, actually, you can do a rough and ready mosaic in Ginga in real time if you'd already done the reprojection into FITS files at the beginning.
Yeah.
Basically, all of this WCS stuff, all of this WCS reprojection, all of this stuff that solar physicists only seem to use occasionally and only since stereo, is all Astro. And AstroPy people need it badly and want to use it all the time. So by using AstroPy WCS and AstroPy coordinates, we're going to get all of this effectively for free.
Right. I mean, it's already there, right, essentially?
Most of it, yeah. I mean, the reprojection stuff isn't.
But it is happening in the background, right? I mean, when these axes are being created, you're essentially doing this.
No, that's
It's
different.
not applying
This
it
is
to the
changing
data.
the data.
Right. But the transformations are happening.
Yeah, the
Right.
transformations are fine. It's,
Right.
Yeah.
You just have to now apply that transformation to the data.
Yeah.
Yeah.
That's a very non-trivial step, though.
Right. But so is rotate in a way.
Oh, you don't have to tell me.
Yeah. Yeah. I wonder if we should have like a map.prep command, which would do like the rotating and whatever else you want to do. Like rotate and then maybe get rid of this like 10H stuff.
No, well, the TAM projection, getting rid of the TAM projection is pretty much pointless for solar disk images. And when I say pretty much, I mean entirely.
All right, but if you're using I'm just saying, well, there'll be like a number of things that most people won't want to do, which include rotate, right? So when you first load the map and you plot it, you would plot it just like what you're talking about here with these nice axes that are correct. And then you'd want to, rotate and do some other stuff. And then you can have a prep command, and all that does is, okay, it normalizes your data onto the coordinate system that you want. And then, in addition, if you now want to transform the data, right, then that's what you're talking about, right? Now you're going from the observed coordinate system to a new coordinate system. And you're applying that transformation to the actual data. So again, you're changing the data, right? Yeah. But I kind of see that's sort of the workflow that most people would go through, right? Like you load the map, you plot it just plots the map data as it is in the file. Then you do a prep command, which would change the data by doing a rotate and whatever else little things it does. Now you have it on this nice set of axes, and then you could transform the data to a new coordinate system.
All of that code we can implement, but I think that we should probably keep most of it as functions that operate on a map, seeing how you are basically completely changing the map. You're no longer returning a map which is same or similar to what it was before. You are effectively creating a whole new thing.
Well, in some ways, that's what submap does, right? Submap does return a map. It's a whole new map.
I don't mean technically all of the map methods return a whole new map. I just mean conceptually you're doing something. That's not the only reason either. I think these things should probably be functions that work on the map rather than methods of the map, because it allows the user more control. Because when you start talking about changing data like that, you really want to give the you really have to give the user as much control as you can. And thanks for a good presentation, British. He's got.
Okay.
Yeah.
Well, I think I'd have to think about that a little bit more.
Problem for another day, anyway. I think.
Yeah, I agree.
I think like AIA prep definitely needs to be its own function, because I am very firmly sticking to the fact that all of the API for the map is the same, irrelevant of what subclass it is.
Yeah. Yeah, I agree.
And that includes a prep function, a prep method doing the same thing for every subclass. Having a method which has got the same name but different behavior depending on the subclass is also not acceptable.
Right. Yeah, I mean the prep class could just do the standard stuff like rotate.
And then you just call rotate.
Well,
what else are you going to add other than rotate?
Well, you may want to resample, get rid of the 10H stuff, for example.
That's such a massive operation that I would think that for practical purposes it needs to be kept outside, because To do that in a flux-conserving manner is ridiculously numerically expensive, and therefore is all in C code. So unless we want to have another C library, which is a hard dependency, we're going to have it separate.
You're arguing from the developer's perspective. I'm arguing from a user's perspective.
From a user's perspective, having things as functions that operate on map. I think we have to have functions that operate on maps. Also, when you do reproject, you have to specify what you want to reproject to.
Yeah, you just like you. Well, I think we should end this conversation here, as we're already half an hour over.
Yeah. Anyway, it's that we're talking about things that aren't going to happen for like another year, so I think we can probably stop.
Yeah.
Yeah.
Okay. Cool. That looks really awesome.
I mean, doing the AstroPy coordinate stuff that British has done opens up a lot of this stuff to us, like a lot of cool stuff.
Yeah.
It makes our coordinate systems talk the same language as the AstroPy ones, and therefore all the AstroPy affiliated packages and other stuff that would use that framework, we get it. Hook line, like we just did.
Right. Yeah.
On the topic of affiliated packages, I pushed a new SEP the other day talking about affiliated packages, so people should check that out. Jack has already looked at my updates to the Lyco SEP that I've completely rewritten, but there's more eyes on that. It's also good. Other news? No, can't think of any other news. I think we're probably done. Unless anyone else has anything to add.
You're not presenting. Have you worked out with Jack about SunPy at SIPWorks?
That's this week. I'm going to do that this week.
Okay. Jack has a poster, and we have a demo session, a 2-hour demo session.
Cool.
Which is basically, as far as I can ascertain, an interactive poster session.
Yeah.
Yeah, we need to talk about some of these things there. Which is time.
I think our plan is to create lots of notebook examples for the demo session. So we'll have lots of relatively short demos of the different things SunPy can do, and then obviously all of those will get pushed back up into the gallery. So hopefully this week, Jack and I will effectively generate a whole shitload of content for the gallery.
Yeah, I would recommend that maybe we build on, like, if you find a notebook that's close to what you want, but add to it as opposed to creating a new notebook, right? Is that you don't want like old unquote out of date notebooks, you know, that people have to kind of sift through, and then there's like newer notebooks that are better. And, yeah. Okay.
Yeah. Okay. Well, thank you very much, everyone.
Yep. Thank you.